Have you ever pondered the possibility of us not being alone in the universe? It's a question that has tickled the human imagination for centuries. Our universe is vast, almost beyond comprehension. It's filled with billions of galaxies, each teeming with countless stars, and circling around many of these stars are planets. Planets upon planets, reaching numbers so astronomical they boggle the mind. Now consider this. In this grand cosmic dance with its near-infinite participants, is it not possible, even probable, that the miracle of life has sparked elsewhere? Think about it. Life, as we know it, evolved on our tiny blue dot in a remote corner of the Milky Way. But if we consider the sheer scale of the universe, the staggering number of celestial bodies, it seems more and more likely that we are not alone. In such an infinite cosmos, could we really be the only ones? Enter the Drake equation, a scientific formula for the likelihood of extraterrestrial life. This mathematical model, conjured by American astrophysicist Frank Drake in the early 60s, seeks to estimate the number of technologically advanced civilizations that might exist in our Milky Way galaxy. Imagine the equation as a cosmic recipe, each ingredient representing a factor required for intelligent life to arise. Let's dive into the components of this fascinating formula. The equation starts with the rate of star formation, averaged over the lifespan of the galaxy. The universe is teeming with stars, many of them similar to our sun. Each star is a potential home for a planet capable of supporting life. Next, we multiply by the fraction of those stars that have planetary systems. With the discovery of exoplanets, we now know that planets around stars are the rule rather than the exception. We then consider the average number of planets in each system that could potentially support life. Here, we're talking about planets that are in the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist. The next factors are the fraction of those planets where life actually develops, the fraction of that life that evolves into intelligent beings, and the fraction of those civilizations that develop technology detectable across interstellar distances. Finally, we consider the length of time such civilizations send out these detectable signals. This is perhaps the most uncertain factor. Civilizations might last thousands, millions, or even billions of years, but they could also destroy themselves in a blink of cosmic time. Tweak any of these variables and the result changes dramatically. Increase the lifespan of civilizations and the galaxy could be teeming with life. But decrease it, and we might be the only ones out here. The Drake equation, while not definitive, certainly suggests that we may not be alone. It provides a framework for scientists and space enthusiasts alike to ponder upon the tantalizing question, are we alone in this vast cosmic ocean? Scene script. Ever heard of the Panspermia Hypothesis? This intriguing theory proposes a fascinating possibility. Life as we know it on Earth may not have originated here at all. Instead, it could have hitched a ride on cosmic dust, asteroids, or comets from a distant corner of the universe. The Panspermia hypothesis suggests that the seeds of life, perhaps in the form of simple microbes or organic compounds, are not exclusive to our planet. These cosmic travelers, enduring the harsh conditions of space, could have landed on Earth billions of years ago, kickstarting the evolution of life as we know it. And this isn't just a baseless theory, there's evidence that supports this idea. Scientists have discovered organic molecules, the building blocks of life, on asteroids and comets. These celestial bodies are remnants from the early solar system, indicating that the ingredients for life have been present in the universe for a very long time. Furthermore, experiments have shown that certain microorganisms can survive the harsh conditions of space, lending further credibility to the Panspermia hypothesis. So, what does this mean for the existence of extraterrestrial life? Well, if life on Earth could have started from elsewhere, it's plausible that similar processes could have occurred on other planets too. Could life on Earth have started from a far-off corner of the universe? It's possible. The search for extraterrestrial intelligence, or SETI, is working tirelessly to answer our question. Let's dive into the fascinating world of SETI, the ambitious project that has dedicated itself to the pursuit of cosmic companionship. To understand the enormity of SETI's task, we must first grasp the vastness of the cosmos. With billions of galaxies, each hosting billions of stars, the idea of life existing beyond our little blue planet isn't just a flight of fancy, it's a statistical likelihood. SETI's primary method of investigation is the monitoring of radio and light signals from outer space. This approach is based on the assumption that an advanced civilization would use such means to communicate across the cosmos. Imagine for a moment an alien civilization turning their antennas towards our corner of the Milky Way, catching a stream of signals we've been broadcasting for the past century. However, this search isn't just about sitting and waiting for a cosmic call. SETI employs sophisticated algorithms and cutting-edge technology to sift through the cosmic noise, looking for patterns or anomalies that might indicate an alien hello. It's like finding a needle in a cosmic haystack. Among its most significant findings, SETI has intercepted intriguing signals like the famous WOW signal of 1977. This powerful, unexplained signal from the constellation Sagittarius has stirred much debate. While it isn't definitive proof of extraterrestrial life, it's certainly a tantalizing hint of what might be out there. Despite the skepticism and challenges, SETI has remained steadfast in its mission. The search is not just about finding extraterrestrial life, but also about understanding our place in the universe. It's about the human need to explore, to reach out into the unknown, and to ask the age-old question, are we alone? While we haven't received a definitive hello yet, SETI's work continues to add to the mounting evidence. Unexplained phenomena have long fueled the belief in extraterrestrial life. Across the globe and throughout history, enigmatic events and mysterious signs have sparked curiosity and debate about the possible existence of beings beyond our planet. Take for instance the intriguing phenomenon of UFO sightings. These unidentified flying objects, often seen as lights or shapes in the sky, cannot be easily explained by conventional physics or human technology. While many sightings can be debunked as misinterpretations of natural or man-made objects, some remain unexplained, leaving us to wonder if they might be evidence of extraterrestrial visitation. Then, there are the enigmatic crop circles. These complex geometric patterns appearing mysteriously overnight in crop fields have left people baffled for decades. Though some have been revealed as hoaxes, a number of these intricate designs still defy explanation. Could they be the handiwork of extraterrestrial beings attempting to communicate with us? Or is there a more terrestrial explanation we've yet to discover? And who can forget the WOW signal, detected in 1977 by the Big Ear radio telescope at Ohio State University? This strong narrowband radio signal lasted for a full 72 seconds, and has never been detected again. Despite extensive efforts, scientists have failed to identify a natural source for this signal. Could it have been a fleeting greeting from an advanced alien civilization, or simply an anomaly of cosmic proportions? Each of these phenomena, in their own way, adds to the intrigue and mystery surrounding the existence of extraterrestrial life. While they do not provide definitive proof, they continue to fuel our curiosity and spark our imagination, pushing us to explore further into the unknown. These unexplained phenomena, while not conclusive, keep the question alive and kicking. So, are we alone in the universe? This question has been the basis of our exploration today. We've delved into the depths of the cosmos, pondered equations, and entertained hypotheses, all in our quest to understand our place in the universe. We began with the Drake equation, a mathematical formula that attempts to estimate the number of technologically advanced civilizations in our Milky Way galaxy. Despite its speculative nature, it serves to illustrate the high probability of extraterrestrial life, given the vast number of stars and planets out there. We then considered the Panspermia Hypothesis, the idea that life exists throughout the universe, transported on meteoroids and other celestial bodies. It's a compelling thought, isn't it? The possibility that life, as we know it, could have originated from somewhere beyond our own planet. Our journey took us to the work of SETI, the search for extraterrestrial intelligence. Their ongoing efforts to detect signals from outer space remind us that our search is not merely philosophical but practical and ongoing. Finally, we looked at unexplained phenomena, those intriguing occurrences that defy our current understanding. From unidentifiable aerial objects to strange radio signals, these mysteries continue to fuel our curiosity and our search for answers. While we may not have definitive proof yet, the evidence certainly suggests that the universe might be teeming with life. Until then, the question remains, are we alone?